Well, hi, good morning. Thank you so much for joining me in my shop here on the 20th of June, 2024. And yesterday I went over this radio, got it operating reasonably well. So that's great. Now we're going to have to deal with its brother here, who has come to the party with no tubes. Oh no, not a tube in this radio. So before tubing it up, I should take a look underneath and just so it looks to be in pretty good shape underneath, aside from the multiple wax capacitors that are in there. It's nice and clean. I don't see any funny business. Looks like nothing's been done in this radio at all. So this is soldered to some tube pins, and I can feel it kind of shaky loose, like a lead that didn't get soldered. But it's just the tube socket pins are loose because there's no tube. No tubes. No tubes. So I have to hunt down 5 tubes. So I've already picked off a 12 SK7. I'll have to test all these to be absolutely sure they're good, or I could fill it with a couple of bad tubes. It takes quite a while to sort that out. Okay, that's what I'm going to do. I continue just scrounging up the necessary tubes here, and we'll get it full and we'll see what we do next. Okay, it's now full of tubes. There they all are. They all tested good. Very good, in fact, the tubes I put in here. Should we just power this thing up? I'll take another look at it. Before I do that, somebody pulled the tubes out of this for a reason. The reason would be it wasn't working and they thought the tubes were the only thing of value. So they took the tubes, somehow managed to sell the radio without tubes in it. So again, it looks to be in good condition. It looks like nobody's done anything under here at all. All original. Maybe not the power cord. I don't know. It's got a little bit of a tricky way they've stood it off here. They've got a tube over the power cord, and then they've knotted the cord on either side with this tube to protect the cord where it's going through the chassis. That's a little fancy. Could be a factory thing. This just doesn't look right. Maybe somebody changed the plug on the cord, cut the cord, and just put this hardware store plug on there. This is not a hardware store plug. This is riveted together, so maybe it is the original. Okay, so we're going to give it a try here. Now, as I mentioned before, I have ways of doing this. So this is tuning, this is band, and this is volume and on off. So we're going to turn it off, make sure the off button does turn it off. Okay, we're going to supply some power to it here. Oh, you see the light come on even though the switch is off. Okay, so this coming on, I think it indicates all the tubes are operating. Well, that's good. I did test them all, so we're getting it. 105 volts. Oh, you know why? I've got both bulbs screwed in. Oh my gosh, here it comes. I haven't got it turned on yet. The volume is 0. So she's humming. Bit of volume there. You know what? You know what's lacking in this radio? This radio does not have an antenna on the back. It's a shortwave radio. The loop antenna doesn't help shortwave, so they just everything on a wire. You have to put a wire out there to get the shortwave working. And I have no idea what band I'm on, and I do not have it hooked up to an antenna. The antenna I have is turned off. Oh my gosh. She's receiving all right. We can guess this is the antenna lead. Well, let's, the hum is not bad either. I'm going to go turn the antenna on. We're going to give this guy a shot. Okay, this is my outdoor lead to my outdoor antenna. I'm just clipping it right onto the insulation of the wire there. Hey, this was easy. That scratchy sound. That scratchy sound strikes me that that's indicating DC flowing through the mechanical sliding connection that is inevitably in these variable tuners. DC, how would DC get through there? I'd have to look at the schematic. I just made this up, but that's what that sound sounds like to me. It's not just dirt. Let's try the other band. And we would want to go, now I just got this loose connection here, it's not very much, up here. Get some noises. That's full volume there. Well, that's not a consequence. Let's see if I can hook this right on to six, 7 megahertz, 8. Anybody here? Seem to come to life right here. Okay. Oh, that doesn't turn it off. Very good. Amazing, eh? It's not just amazing. You can just pop some tubes in and turn a radio on like this and have the thing work. Why somebody abandoned this radio, I don't know. They don't like it. They thought it was ugly. I don't know. But then again, they didn't throw it away. Usually, when you yank the tubes out, you throw the chassis away. You don't keep them laying around, unless you're like me. So that's a little odd. The purchaser knows enough to look for tubes, but I guess they didn't look through the little window here to see if there were tubes in the radio before they bought it. And I think they paid $10 for this, so no. $10. But now it's got, you know, what are these tubes worth? Well, on the open market, like to actually buy a full set of these tubes, it's got to be $20 a tube anyway. So that's $100 worth of tubes gone into this radio already. Okay, that's pretty good. I'm going to take a little break now and ponder what to do. I got these two like working but not in top condition radios to deal with. Interesting. Let's compare these two radios. First of all, the interesting thing is the chassis is absolutely identical for both radios. You see these extra parts here on the shortwave radio. One of these is going to be an antenna coil or oscillator coil, I'm not sure, for the broadcast band. The other one will be for the shortwave band because there are two bands. Over here, that same thing, I'm guessing, is underneath here somewhere, right there. screwed to the side, screwed to the side. It's still there. Well, I'll correct myself now. So this radio operates with a wire antenna. There is no loop antenna. This one operates only with its loop antenna. Really not meant to have a wire antenna on it, although it has some facility somewhere for maybe coming off of here, coming off this terminal where the capacitor is. Extend a wire if you wanted to. The loop is one of these. So that's why there is no similar coil here. It's there. It's the antenna itself. See all the drillings here and the holes and all that, and here's the stuff that goes in those drillings and those holes. Now what else is different here about these radios? From there, not a lot different. This is lower down. This is higher up. This is higher up. To for what reason? And it has the band switch here. You can see the bracket that they used to. Can you see it down here? There's a bracket they've used to elevate the capacitor. So exactly why? Can't really see from up here why that would be. In this case, the trimmer capacitors are right on the tuning capacitor, and they're easily accessible with a screwdriver like this. Over here, no, these capacitors are disabled, they're gone, and there's nothing on the other side either. So these trimmers, I don't think they're the same as this. I'm going to guess these are the oscillator coils, but I'm not sure. Let's find out why is that capacitor up. Well, there's no. Well, here's the switch. It doesn't extend across as I kind of imagined it was extending through here and needed space. No, this doesn't need any extra space. You can actually see in this radio the drillings are there for it. It's all ready to go. Maybe what's happened here. No, I was going to say maybe they had to elevate this piece. Now wait a minute. How can the capacitor be elevated on one of these and not on the other, but this isn't the same height? Okay, wait a minute. There's something funny going on here. No, this is higher than this. This goes in the same cabinet. How can it go in the same cabinet? How can it fit in the same cabinet? Exactly the same. Because I don't know exactly how you fit that in exactly the same cabinet. Are they exactly the same? Maybe they're not. Here's one cabinet. Here's the other one. Okay, just back up a little bit here. I mean, these look exactly identical. They are. They're identical. Except this one has an extra hole drilled in the cabinet. They wouldn't want to make two different kinds of cabinets if they could get away with making one. All purpose. Yeah, the holes are drilled the same where they exist. Just pop an extra hole in it and shortwave. It is. I don't understand. I don't have to understand. Maybe I'll understand further down the road. I'm probably making some weird false observation here of some sort. Of course, this one just sweeps over the top. So you could have the bottom, of the display here. But this one, if you put the bottom of the display there, you wouldn't see this. So they've had to shrink this and elevate it a bit to get it in the window, to get this in the window. That's my guess. This is that wide, I don't know. This seems... Anyway, okay, enough. Am I getting carried away there? Too much focus on that. What other differences are there? So I think the interesting thing is the tremendous similarity in the radios beyond this front end thing. Everything looks the same, except here they've used, as I noted before, a 6K7, but here they've got a 6SK7. Just seems strange to me that this tube would be here again. Maybe they had a pile of them in the warehouse and I don't know. I don't know. They got a good deal on them. Because the tube manufacturers, they had a warehouse full of these guys that were going out of service because they've been replaced by the single-ended version. So maybe they sold these cheap. And I don't know. I like making up stories. Okay, let's look underneath, and we'll compare these two radios underneath. Very nice that you can flip these right over. Okay, this will probably be best this way, like this, like that. And then you're going to go up just a little higher. Okay. Now, of course, some work's been done over here. So, for instance, we have a replaced filter capacitors, not here. Still on the same original filter. In fact, everything here is original. You know, that's something to think about. If it's all original and it's operating, maybe it's best left alone. A bit of a risk there, especially with the output tube. The capacitor whose job it is to let's say protect the grid of the output tube will almost certainly be leaky if it's one of these guys. We should find that out. The output tube is, be careful I don't put my fingers through the speaker here, right here. Output tube. Things look a little different here. This hot resistor here, it's back under here on this radio. And we're down in the audio area, and this is the rectifier tube. This guy has replaced this guy. This guy must be this guy. There's one down here. That's this one. This one down here is this one. This guy is going to be this one. Oh, where'd this one go? Capacitor missing. Capacitor missing. Come over here. Now we're in the front end, and it's a little bit of a different radio. It's got two adjustments here, and oh, look, there's an additional coil. Just thrown in, just jammed in here. Looks to me like that's not particularly engineered into a spot. Looks like that's the only available spot. So this is identical, and then we have one here. It's probably this one. We have two more. Probably this is one of them. And we got an extra capacitor here. Here they've put in a terminal strip mounted onto the back apron. Here they just have a single terminal. I wonder if that's reflective of the fact there's more bands in this radio. The general construction, pretty identical. I just let my eyes go back and forth. You really can't see any construction type difference. That's my own work there. It doesn't look very well soldered. So, what do we do? They have both radios operating. Both have problems. The one from that I played yesterday, bad audio distortion on high volumes. This one I don't know about. It didn't sound so great. weak, generally weak. So I think maybe what we can do is we can start with the output tube and the capacitor that's protecting the grid of the output tube. It's a 50L6 and a 35L6, but I bet you the pin arrangement is the same. Look at yellow wire, blue wire. Hope these aren't plugged in. Red wire, two red wires. Resistor, 22K. They just have installed it differently here. Oh, it made a bigger difference because there's a resistor here. I don't see it over here. Instead, I see this one swung over. So maybe a little bit of a difference in wiring here. We are down towards the front end of the radio where the differences would occur. Terminal down to ground, down to the same thing here. Very, very similar, of course. There's a band switch holes here. The band switch installed there. This resistor's gotten much hotter here. You can see some heat effects on the apron, or it look like heat effects, and this looks like it's been pretty hot. This one, the other one on this radio does not appear to have been nearly as hot. It's kind of tucked in behind, pretty close to a tube socket. This is a better arrangement here in terms of heating. Hey, they expected this to get hotter for some reason than this one. So the engineer decided to position it up here. Again, just making this stuff up. I'm spending time looking at this, trying to spot things. Well, I did say starting with the output tube, and then I've drifted off into general gawking. So in the output tube, we want to figure out which pin is the grid. The grid is going to be fed by through a capacitor. I'll bet you it's this one right here. Fed through this capacitor from this tube. And there's a fairly large resistor here heading for, it looks like, the chassis or ground. I can't really see what it's doing. It's going to this terminal. This terminal is going all over the place. This is probably a grounded terminal here. So, but I gotta be sure about this. So, if we get the tube manual out, and we look up, let's say 35L6. 35L6. And we look for the grid. Pin 5 is the grid. Pin 5 is the grid. It's going to be the same on the 50L6, I'm sure. 50L6. 5. Wait a minute. Wait. I think I'm thinking of the previous radio. Yeah. Previous radio had a 6F6 output and there was a 6V6 in the tube. Don't think I commented much about it. And it just crossed my mind here. And unfortunately, it's the wrong radio I'm thinking of. Or fortunately. So, 5. 5. What's hooked up to 5? Let's do this radio. It's a little easier to follow. There's the key on the tube. Yep. 1, 2, 3, 4, 5. Just like I had guessed. This is the grid. Likewise, this is the grid. So what's happening here is this capacitor and this capacitor are doing the same job of holding back about 60, 70 volts from here getting over to here. That's its job. If these are leaky, even in the slightest, and you can bet this one's leaky, you can probably bet this one too, then the voltage here will not be what it should be. The voltage here should be 0 with respect to the chassis, but it'll be pushed higher from the leak coming through the capacitor, and it'll start to undo the bias. Now, the tube is getting biased from a cathode resistor, which I believe is this one over here, which would be this one here. What am I thinking this is? This might be this. Not sure. Not sure about that. But there's a cathode resistor in here somewhere. And then the bypass capacitor is this little one here that I install. Actually, we can follow the wire. The brown wire. Yeah, it goes, yeah, you know what? This is a cathode resistor here. And the value is brown, green, brown. It's 150. I've gone over this before. So over here, looking for a cathode resistor, there's one here. It's red, red, brown. So this is 220 ohms. They have a different size. Cathode resistor, it's a different tube, right? It's a 50 L6, a 35 L6. But I wouldn't think they get biased differently. So what we want to do is we want to measure the voltage here and the voltage here on both radios. See what the, let's call this the input side or the high voltage side or the plate of the previous two is what it really is. It's going to have 60 or 70 volts on it, and over here it should read 0. But I bet you we'll find that it reads 2 or 3 volts. So let's say it's 2 or 3 volts here, and the cathode resistor is providing a bias of, let's just guess, 8 volts. That 8 volts will be reduced by the 2 or 3 leaking through. So the bias is reduced. If a serious leak, you can get down to no bias. You can get it flipped around the other way and have the grid positive. That would be cause a lot of distortion. And also the thing about this, I didn't mention this, is the positive grid, or that lack of negative bias on the grid of the output tube, causes the output tube to conduct more current than necessary when it's just operating. And that more current is wearing out the cathode. Also, if the current is high enough, it's going to heat up the plate. Actually, you can overheat the tube in a really bad situation. I don't think I've ever encountered that. I don't think it would last long, frankly, if the situation got that bad. So we do a test, both sides of the capacitor, replace the capacitors, do a test, see what's up. But really the first thing I got to do is stop and have some coffee. Okay, if you're hearing a roar in the background, that's my air conditioner going in my home. Okay, so this is the negative lead, or the common lead from my voltmeter here. I have to decide where to put it. I could put it on the chassis. But the instructions actually say their voltage measurements that appear on the schematic were made with this connected to the B-. Now that's a bit of a scary operation. If you plug this kind of radio into a regular outlet, yeah, I don't know about that. That could be pretty scary stuff. This can be grounded to the hydro here in my shop. This is grounded back, even though the meter is a 2-prong unpolarized plug on it. I have a ground wire. You can just see a little bit of it there, a little bit of yellow, and the green wire you can kind of see running around here. It's tying together all the metal cabinets that are in my shop and tying them right to hydro ground. Now this is not grounded. This is coming from an isolation transformer. So what I can do is I can clip this onto the B- point. Now I've picked off a B- point in both radios and put a clip lead on it. So the B- point, or the neutral point, I don't need to use that word, is here and here. I could probably put these together, but I'm not going to. I'll do them one at a time. I'm going to start with the radio we were just operating, which is this one, which is the shortwave one. So I'm going to hook my meter here. The reason for doing the clip leads is because I'm going to go back and forth if I would make a mistake. So with the clip leads, I'm much less likely to make a mistake. Okay, we're tangled up here. Okay, we're set to DC, and I'm set on 15 volts full scale on the meter. Positive full scale. Is that right? Yeah, it's a positive voltage we're worried about. So on one side here is the plate to the previous tube, to the triode that's feeding the output tube. The plate is running 60, 70 volts, something like that, not very high. And on the other side, we should get a 0 when I do this. Let's see what happens. Actually, it's this radio though. Don't get confused. See? It doesn't take much to confuse me. Okay, first we're flipping it on with the dim bulbs in the circuit. Everything looks fine. That's running with 102 volts. Let's leave the dim bulbs in. I'll crank the voltage up that way. Okay, so we're 112 volts. Not that that really matters for this test. Now, should we hear the radio operating? No antenna. Oh, I can hear it clicking there. Okay, we're good. Now, on the plate side of this capacitor, watching the, oh, this is going to be more than 15 volts. This might be, well, we're going to find out. So, 50 volt scale, it's pretty low. 35 volts, that's awfully low. 35 volts on that side. Now on the other side, we should see nothing. No. Look at that. So that voltage, 15 volt scale now, that's a bad actor. That's coming up 7 volts. Bad boy. Okay, cut the power off. We're going to switch to the other radio now. Because I got them powered from an isolation transformer, it doesn't matter which way I plug this in. It's no. Okay. Sometimes I can't finish my sentences, so I just cut them off with the last word there. Now we're going to do this guy. It's plugged in. Just turn this back a little bit to start. Here we go. It's not turned on. Not turned on. Okay, it's on now. There we go. That's more like it. The reason I knew it wasn't on was I expected dim bulbs to pop up, but they didn't. So, dim bulbs. A really good, really good device. Really good way to go. Not a device. Method. Okay, and we're going to go on the voltage now a little higher. You can hear the radio. My favorite interference on it. Keeps drawing down the voltage here. 105, a little more. That's good enough. Again, we're not looking for precision here. It's kind of a go, no go. Listen to that. What could that possibly be? Making that tick. I don't know. It's an enduring mystery. We'll now check the plate side here, and we should expect, I think, 60 or 70 volts. A 150 volt scale. We only got 35 on the other radio. Oh, this one's going to be the same. 50 volt scale. So 35 volts. Does seem low. Now we'll go on the other side. And it's going up also. And the 50 volt scale will go to the 15 volt scale. He's worse. 10 volts. Now, with this still operating, we'll try to figure out what the bias is supposed to be. I'm going to flip this to... No, it stays positive. And look at the cathode, I believe. So this is the cathode bias voltage. I should have done it on the other radio also. It's just about exactly the same. So this radio is operating with basically no bias on the output tube, and remember the distortion that it was producing? It was terrible. Turn it off, because that'll guarantee a heavy current flowing through that tube, but of course I'm not necessarily operating a radio at full line voltage, so that's, and you know, a few minutes here and there is not going to do anything. We're talking about hours of operation with excess current going through the cathode, wearing it out. So next step along the way here is extract these two capacitors and test them and see what the story is. So let me just pull the plug out here. Okay, a little safety procedure that I tend to forget about, and I need a couple clip leads so I can mark the location of the oh, come on. Oh, smokes. Give me a clip lead here. We'll cut them out. Yeah. These are brand new. Felt like the blades, instead of hitting, it felt like they went like that. My brand new ones. Okay, put the clip lead on before you already blow it. I'm also leaving a bit of wire there, also as a marker. There's one out, and the molded one has come. Oh, you know what? I didn't rate these. I set this up to make notes. Didn't bother making any notes. Don't bother now. Okay, and then this one, same deal. Okay, let's go to the capacitor checker and see what we got here. Hey, are these the same size even? I don't know. Let me just... Okay. Let's do the molded one first. So the molded one came from the broadcast only radio. The one that we heard the audio distortion. 0.05 is the size, quite clearly. 0.05. What about the other one? 0.01. What? It's quite different. This is a replacement, I bet. And the guy probably stuck a 0.05, he didn't care. Again, I'm just guessing and making stuff up. Okay, 50 volts, watching the eye. What can you do? You can do nothing. You're a piece of junk. We already know that because of the way the radio operates. Pretty far-fetched that's not, due to leaks in these capacitors. And even though this one has a molded shell, a plastic shell, inside it is the same thing, I believe, as this. 50 volts. What do? You're a goner. You're just a piece of junk. You're not capable of doing your job anymore. You must be retired. You're finished, buddies. You're out of it. You did your job. Now it's time to go to the retirement center, better known as the landfill. So I'm going to put in a couple new capacitors. Check the schematic and see what it's. Let's do that. I can do that. Let's check the schematic here and see what it says. Okay, we're looking at the broadcast receiver here, and we're talking about the grid here on the output tube. We'll follow it along. And here it meets up with the blocking capacitor, C21. Now this is the molded one, the 0.05 that I took out of the radio. 0.05. So C21, and we will look on the list here. C21, 0.01, not a 0.05. Would this make any difference? Probably not much, really. It's probably pretty harmless to put a bigger capacitor here. You might change the tone quality of the radio. I suppose that's possible. So bigger capacitor going to let through more lows. So you see, you might get a bassier result. I don't know. We'd have to experiment to find out. 0.01 is what I'm going to put in though. Let's look at the other radio. And look, it's written right on here. 0.01. Right there. 0.01 is the name of the game. Fantastic. I'll put them in and then we will repeat the tests and see if we haven't helped both these radios out. Okay, I've got the two capacitors in and ready to go. Just turning off my soldering iron there. Okay, we will start with, do it the same way. We'll start with, I don't know which way I did it last time. We'll start with this guy. They were very similar, weren't they? So, okay. Connect this here. Yes, I must have started with this one last time. It was like 35 volts and 7 or 8 over here. Okay, are we ready? I'd say so. Give her a bit of time to warm up. So what I'm doing here is I'm making the radios, both radios, safe to operate here on my bench. I'm removing situations that are detrimental to the radio if you operate the radio, so I can carry on operating it and fooling with it. It's pretty hummy, isn't it? Well, not that bad actually. With its original filter capacitor. Okay, watching the meter here, and we're on the 50 volt. First of all, on the plate side. So 50 volts there now. Huh, 112 volts supply. Well, so that jacked it up. I don't quite understand how that would jack it up. There's no way this was leaking so much. Now we'll check the other side and find out, is there egg on my face? The meter didn't move. 1.5 volts full scale. It's a little off the zero here. Tiniest amount. And that voltage, that could be coming back from the tube. So we've removed the positive grid bias problem here, or not negative enough grid bias problem. Now we'll go to the other radio. We'll see if the same thing happened over here, including the B plus going up, which is the B plus supply to the detector tube triode going up. Okay, just back up on 50 and power it up. There we go. This meter, because you can see it going, this meter doesn't go to 0, it goes to 100 volts here at the bottom. So until there's 100 volts, this meter doesn't see anything. At 100 volts it starts coming up. So it's 100 to 140, but it's not very accurate. But you're seeing it move. And this one is reading the line voltage, which you cannot see. This one here is reading the line voltage all the time. And the guy in the middle, he's from Florida. Okay, radio's operating, we can hear it. Voltage is 110. On the plate side, 50 volt scale, plate side, right over. Well, I just can't imagine that a leak through this capacitor was pulling that voltage down, but how else do you explain that? Okay, on the other side, make sure you touch the right thing here. See nothing? We'll go down 1.5 volts, full scale. Watch your hand here. Ooh. Something just changed. Don't know what that was. It wasn't me. Same sort of deal. Slight rise. Yeah, watch it because the B plus is right beside it, I think. Okay, there we go. That's it for today. So if the output tubes were getting the crap beat out of them before, they're not now. We should have listened to this radio for distortion. Well, we can still do that. Because I think I have the antenna connected. Let me get rid of that stuff. I'll get rid of this. Make sure I've got the one plugged in. Yes, this is this one. I'm going to flip it over. Power's off. When you're flipping it over, if you get a little brush shock, there's a good chance you'll throw the thing. You'll throw it somewhere. That's why I'm so concerned about the power being on when I pick up radios on my bench. Get this out of here. Too many cords in the way. Get this right out of here too. Just take it right out. Take it right out. Right out. Okay. So, question is this guy still producing distorted sound? Now, I was boosting my outdoor antenna. We're going to do that again. I'm not boosting the outdoor antenna. I'm using the outdoor antenna to boost this radio. Volume down. Power in, power on, power on. Dim bulbs in the way, but that's okay. I can leave the dim bulbs in sometimes when the radio's not drawing too much current, and I can jack the supply voltage up to compensate for the small drop in the light bulbs, which is what I'm doing. So I can leave the dim bulbs in.
More news. Extreme weather has pushed insurance claims up. More talk. Think about getting my child into child care.
So we need to crank the volume up here. Whatever sounds better to me, though. Okay, tune it in nice. Oh my gosh, we're way up band here. So this looks like 1150. This is Hamilton.
America 2024, Argentina, Canada, tonight at 7.
Okay, I should have warned you before I cranked the volume up, but no distortion. Distortion solved. Very good. Ooh. Bit of a wild volume control there. Oh yeah, no on-off switch. Oh, there it goes. I'm just too weak. Well, thanks a lot for watching today. I hope you found that interesting. Doing two radios at once is kind of interesting, even though there are some differences between them. But great. I'm done for today. Thank you so much for keeping me company here, and thank you for clicking the like button, and super thanks. Thank you very much. Appreciate it. See ya.